So let's do some practice for a bonding quiz. Going to have to know how to do naming and formulas and identify ionic versus covalent, and also talk a little bit about the properties that we talked about in class last time. Okay, so first job here, which of the following are ionic? You should definitely have a periodic table handy so you can look and check to see what kinds of elements we've got present. Okay, so you should have said, in terms of which ones are ionic, you should have gone with the first one because it's got nickel in it. Nickel is right here. It's a metal, so this is ionic compound. Same for strontium. Strontium is right there in the S block. That's a metal. Strontium, so strontium nitrate would be ionic. Cl2 is just two chlorines. That's two nonmetals bonded together. Then we have magnesium acetate, so that would be ionic because magnesium, once again, is over here on the right-hand side of the periodic table. That's a metal. And then finally, NH3 is not. That would be covalent, two nonmetals. Even though hydrogen is way over here on the periodic table, it is still considered a nonmetal, so NH3 would be covalent. So the next question is, name the previous compounds. So the first one, NiCl2. See if you can come up with the name. Okay, so Cl is in group 17, so it has a -1 charge, which means that two of them would total out to -2. And if we want our total charge on the compound to be 0, which we always do, the nickel would have to be +2. And since there's just one of them, this is nickel 2. And the reason I went through all that is because nickel is a transition metal. It is, as I said earlier, up here, this part of the periodic table. So it's a transition metal, so it does need a Roman numeral, so that's why I went through all that. So this is going to be called nickel 2 chloride. Don't forget the "ide" ending on the anion. The next one up was SrNO32. Okay, so this one would be just called strontium nitrate. No Roman numeral because strontium is in the S block. It has a constant +2 charge. So we don't need a Roman numeral. In fact, you should not have a Roman numeral. And the nitrate is just the name of that polyatomic ion. All right, and then we have Cl2. Well, that's just a molecule, so Cl2 would just be called chlorine, so you don't really have to worry about naming one like that. And then MgC2H3O2. With a 2, and this one would just be called magnesium acetate. Again, magnesium is not a transition metal. It's in group 2, so it doesn't have a varying charge, so you do not include a Roman numeral. And since this is ionic, we're not going to call it like diacetate or anything like that. There's no prefixes given with ionic compounds. All right, and then the last one, NH3. So we already said that's covalent, which means it does need prefixes. So this one would be called nitrogen trihydride. Now this is a common gas. If you look it up, it'll tell you that it's called ammonia, but don't worry about that. We're going to use the systematic way of naming these molecules using the prefixes if they are in fact covalent compounds. Okay, let's try a couple where you give the formulas. Barium acetate. Okay, barium is in group 2 of the periodic table, so you should have found that it has a 2+ charge. Acetate is the polyatomic ion, C2H3O2, with a 1- charge. So you will need 2 acetates. So I'm just going to rewrite this. Ba, C2H3O2 in parentheses, and we need 2 acetates. Next up we have carbon tetrachloride. Okay, so this one is covalent, which the prefix tetra tells you, plus it's 2 nonmetals, carbon and chlorine. So you don't have to do any math here. You just go by the prefix. There's no prefix on the first one, which means it's 1, because we dropped the mono off the first. And then the tetra means 4, so CCl4. On the quiz, you'll be given those Greek prefixes. You don't have to worry about memorizing those, but it would be CCl4. And finally, not finally, we have 2 more. Next to last here, copper 1 sulfate. Okay, so if copper has a +1 charge, sulfate is from our list of polyatomic ions, and it has a 2- charge. So you should have said that you would need 2 coppers for every 1 sulfate. And then finally, this is the last one, lead 4 carbonate. Okay, so if we have lead with a 4+ charge, carbonate is CO3 2-. The least common multiple is 4, so we only need 1 lead because it's already +4, but we are going to need 2 carbonates because 2 times -2 would give you -4, and that would cancel the +4 charge on the lead.